So let us talk about moments of a random variable. So that's what I mean. You'd like to see what is the expected value of x minus nu. And expected value of x minus nu whole square, expected value of x minus nu whole cube and all. And these are what we will define to be moments. And this is what we call first central moment. Okay, whereas this one we call second central moment. So, and we are going to denote this one as nu 1 for the first central moment, and the second central moment will denote with nu 2, and the third central moment, that is nu 3. So now if you look at rth central moment, so let me define nu r, that's what rth central moment. That's what expected value of x minus nu whole power r. I hope you know how to calculate this. Suppose if f is discrete, if x is discrete, then this is summation, x minus nu whole power r into p of x, summation over x for a discrete random variable. Whereas if it is continuous, this is x minus nu whole square into f of x. Sorry, it's not square, this is power r, where integration over minus infinity to infinity into dx. This is what for a discrete random variable, and this is what for a continuous random variable. Okay, so these are what we call central moments. And similarly we define moments about a point. It means instead of taking the mean, this time we'll take expected value of x minus a. So this is what we call first moment about a. Similarly, the expected value of x minus a whole square, the second moment about a. So expected value of x minus a whole cube. Okay, so this is what we call first moment about a. And of course, you can similarly see what is the rth moment about a. Okay, and these moments will help us to understand probability distributions, the central moments and non-central moments. Okay, and you are going to see use of these when you look at the moment generating functions and all. So right now I can say that these moments will be helpful us to understand the distribution, probability distribution. See, sometimes instead of giving the distribution, they'll give you the moments, and from that they'll ask you to conclude something. Okay. So this is what about the topic mean and variance of a random variable. Okay. So now let us look at one special type of random variable. And it has a name, it is called Bernoulli random variable. So let me tell what it is. See, when you perform a random experiment, if you have only two possible outcomes, or I shouldn't say two possible outcomes, or I should talk in terms of a random variable. Okay, so let me suppose you have a random variable x. If it takes only two possible values, then we say that random variable is a Bernoulli random variable. I mean, for example, you are tossing a coin. When you toss a coin, my interest is to see whether you get head or tail. If you get a head, I'll term it as success. Now I assign the value 1 to the random variable. Suppose if you get a tail, I'll term it as a fail. failure, and I'll assign the value 0 to x. It means if you get head, you get the value 1. If you get tail, you get the value 0. It means now your random variable is taking only two possible values, either 1 or 0. Or in other words, here you are interested in either success or failure, that's it. Similarly, you take a rolling a die. When you roll a die, I'll say that if the outcome is even, I'll take it as success. If the outcome is odd, I'll take it as a failure. Okay, so now I'll define my random variable. For if it is a success, I'll assign the value 1. If it is a failure, I'll assign the value 0. You may ask me one thing, sir, why are you taking always 1 and 0? Okay, if you don't like them, okay, for success you give 5 and for failure you give 10. No matter. You're just assigning a value. For success you're giving some value and for failure you're giving some value. That's it. Okay, or maybe you can take in terms of money. If you get a success, you'll get $5 or 5 rupees. When you get a failure, you'll get negative 10 rupees. So now our random variable is taking the price, cost of the experiment. If you get success, you get 5 rupees. But if you get a failure, you get negative 10 rupees. It means you have to pay 10 rupees to them. Okay. So let me write here what is a Bernoulli random variable. A random variable x is said to be Bernoulli it's a scientist name, okay? So Bernoulli, if it takes only two values. Okay, and we can define a Bernoulli experiment. We say a random experiment is Bernoulli experiment if it has just a success or failure. If it has just success or failure, we say that that random experiment is Bernoulli experiment. Or if you perform that experiment once, that is what we call a trial. So we call a trial is a Bernoulli trial when it has only success or failure. So Bernoulli trial if a trial gives either success or failure, we say a trial is a Bernoulli trial if it gives either a success or a failure. For example, you can take tossing a coin. Okay, so this is what example 1. And example 2, you can look at rolling a die. So now it's not just rolling a die. You should understand what is that you are interested in. So you roll a die and see if the upward turn number is even. Or rolling a die for an even number. It means if the shown up number is even, I take it as success. If shown up number is odd number, then I'll take it as a failure. So that is also Bernoulli trial. Okay. So when you write an exam, that also you can take it as a Bernoulli trial, right? I mean, you can take a multiple choice exam. It's not the descriptive type. So let's assume that someone is conducting an exam which contains 10 questions, right? So there I'm going to the exam without any knowledge. I'm simply answering the questions and coming back. ABCDs only, no? So I'll just uh, I, either I'll roll a die or I'll toss a coin. Accordingly, I'll pick up the options A, B, C, D, one among A, B, C, D. So I'll randomly answer them and I'll come. So there in that trial there are only two possibilities, either success or failure. That's it. If you get more than 5 correct, we treat it as a failure or success. If less than 5 are correct, then we treat it as a failure. Okay, so that is also a Bernoulli trial which involves only success or failure. And of course, answering each question, you can take it as a Bernoulli trial. It's actually a Bernoulli trial which is combination of many Bernoulli trials, because when you answer a question, when you're picking an option among A, B, C, D, that may be correct, right or wrong, right? You may get success or a failure. So answering the first question itself is a Bernoulli trial. Second question, that is another Bernoulli trial. Third question is another Bernoulli trial. So that way you're actually performing this Bernoulli trials for 10 times. Why? Because there are 10 questions. Okay. So now let me give an example of a Bernoulli random variable. So x is equal to, it is 0, or let me define with a random experiment. Let's say our random experiment is to tossing a coin. Okay, now my random variable x, I'll define it to be like this: 1 if head appears, and 0 if tail appears. So this is an example of a Bernoulli random variable. Now see, you can clearly observe that this is a discrete random variable. Why? Because it is taking only 2 values. So Bernoulli random variable is a discrete random variable. Now my question is, what is the probability mass function? What is the probability mass function? It means you should tell me what is the probability that x is equal to 0 and what is the probability that x is equal to 1. At least in this case, when you toss a coin, what is the probability of getting head? What is the probability of getting head, sir?
One by two, sir.
Yeah, 1 by 2. So 1 by 2, and probability of getting tail?
1 by 2 only, sir.
1 by 2 only. So this is the probability mass function of this Bernoulli random variable. Okay. Now let me define another random experiment. So that is also Bernoulli. Now the random experiment is to rolling a die. So when I roll a die, I am giving numbers to x. So I'll take the value 1 if this die shows up 1, 2. If it shows up 1, 2, I'll assign the value 1, and I'll assign the value 0 to x if die shows up 1 among these 4, that is 3, 4, 5, 6. Okay, so this is what my random variable. So it is clear that it is Bernoulli random variable. Now my question is, what is its probability mass function? So it means all that you need to see, what is the probability that x equal to 0, this probability you need to tell me, and what is the probability that x is equal to 1. So these are the two things you need to tell me. Can you tell me? When you roll a die, what is the chance of getting either 1 or 2?
Two by three, sir.
Yeah. So probability of getting 1, there are actually two possible outcomes out of 6. 2 out of 6. That is what? 1 by 3. It's not 2 by 3. So 2 by 6, that is 1 by 3. And probability that x equal to 0. So x will take 0 if any one of these values comes. That is 3, 4, 5, 6. There are how many favorable outcomes? 4 favorable outcomes are there out of 6. So 4 out of 6. That is 2/3. So now the probability of getting success, we take it as P, that is 2/3, sorry. So the probability of getting success is this, 1/3. And what is the probability of getting failure? Q, that's what exactly 1 minus P. So that's what 2/3. Okay, so now let me define what is the probability mass function of a Bernoulli random variable. Let's say x is taking the value 0 and 1. Okay, so now the probability mass function, let me define it as P of x. So that is defined to be P, where P is the probability of getting success if x is equal to 1, and it is 1 minus P if x equal to 0. Okay, don't get confusion between this capital P and small p, where P represents the probability of getting success. Okay, there is no need of taking 1 and 0. If you want, you can take A here, and if you can take B here. A for success, B for failure. No issue. Okay. So this is what about Bernoulli random variable. So the next we need to talk about binomial random variable. Okay, so before that, before discussing binomial random variable, I request you to look at these formulas. Binomial expansion of x plus y whole power n, and next the multinomial expansion, that is x plus y plus z whole power n. Anyway, for tomorrow this is enough. X plus y whole power n formula. Okay, so I'll stop it here and let me know if you have any questions or doubts.